Right, here we go with the first of my videos about Raspberry Pi controlling robots or RC cars. So what I'm going to try and do now is to experiment with a few sort of reclaimed or remote control cars and try and make them run rather than buying kits. I've got a kit already, but this is a Lego one I got from charity shop for a couple of quid. It's got two DC motors in, one to drive the wheels forward and backwards there, and another one for steering. So I've got Raspberry Pi with two motors connected to GPIO pins. I've got the H Bridge there. There's a power pack, 6 volts powering the motors. Motors should only need 4.5, but 6 will do. Got a couple of LEDs, and I'm using up and down, left and right, and I'm using Scratch just to test it out basically. So the way the Scratch is working is I'm setting up the pins to be out, send a signal out, and then every time I press a key it sends a signal to one polarity of the motor, either turning it left or right, spinning it left or right. So for the steering it spins it one way. If I press my button, so that Scratch code works by just turning the motor on for a millisecond and then off again when I tap there. So it's quite sensitive, but how that's going to work in practice I don't know. But basically what I wanted to do is see if I could get this thing to steer. I'll rip the top off in a minute and show you the guts of it, but I've got those both motors hooked up to the H bridge. So I've only got two motors, one at the front doing the steering, one at the back that drives both wheels. And I've got a couple of LEDs which coincide with me turning the steering left or right. So that's like a kind of a rack and pinion motor basically, and then it just comes to a stop and stops the motor turning. So it's quite crude, but it will do the job. And then if I pick it up and just show you the motor spinning, so that's basically hacking a little Lego toy. Really, it did have a remote control with it already that was sending signals to it, but I just ripped it apart. Just wanted to see if I could drive it with the Pi, and it works a treat really. So I've tried it with a little Bluetooth keyboard, that works fine. So the next stage is to make this truly remote by mounting the H bridge and the battery pack and a battery pack and the Pi on there. So I'm going to use a Pi 0 for this, so that'll be the next stage. So just to give you an idea of what this Scratch program's doing, as soon as I turn it on, it's turning the GPIO server on using that broadcast function, and all of the pins, which are 2 pins for the steering motor and 2 pins for the driving the main wheels motor, and a couple of other pins for LEDs, is setting those as output. And then I've got a series of commands, so every time I press either up, down, left or right, it sends a signal to one of the pins and turns the others off, apart from some LEDs. So I'll have one sort of loop, nested loop there for each one of my left, right, steering, or forwards or backwards, and the space bar turns them all off. So I've got like a forever loop there, and I've got an if statement and then and an else statement. So each one of those nested loops. And what I've got there for my left and right is I turn the pins on and then immediately off after a microsecond. So that makes it quite sensitive. So to give you an idea how this H bridge is working, I've got 4 pins over this side here. You can see these four pins here coincide to 4 pins GPIO pins on the Raspberry Pi. Then these 2 pins here, the one that says VCC is the positive terminal of the battery, and the GND is the negative terminal on the battery pack, on the 6-volt battery pack I've got down here. So that's the inputs from the Raspberry Pi powering the motor, which is important so you don't power it off the Pi. And then on this side you've got these 2 terminals go to one of the motors, which is driving either the wheels forwards or backwards, and these 2 terminals here drive the second motor, which is the steering one. So this particular H bridge configuration only drives 2 motors. You can get them that drive more, but this was about £3. So this has got to be mounted on the Raspberry Pi. So you've got your inputs, 4 inputs, GPIO pins, battery pack to power the motors, 6 volts currently, and in your output terminals here, 1 pair there for one motor and 1 pair there for another motor. So what I'll do before I take the bottom off, I'll just turn this upside down to show you the steering mechanism here. You've got like a rack and pinion here, or a rack, which is a little cog on the motor which drives these wheels. That's signal one way from GPIO pin, and that's another signal the other way. So that's just a DC motor turning one way and then the other way, which in turn turns this rack. And then at the back you've got the motor in there which drives both wheels backwards and forwards. And there's only about 3 screws on the bottom, and ideally I could put my 4.5, 3, 1.5 batteries in there, give me 4.5 volts. I've got 6 running through it at the minute, but it'd be quite nice to get 4.5 volts nested in there, and that will take a lot of space off the top of the Pi. So I'll look at that later. That's basically the underside of the car before I take the bottom off. So we're looking at here is the motor which drives the wheels forwards and backwards, both wheels. So you've got a set of gears in there and an axle, so that makes it quite neat. And then at the front you've got another motor there, which is the one that's connected to this rack and pinion. So just steer the thing left and right. So that's our 2 DC motors. Whereas normally on the Raspberry Pi robots you've got 1 motor for each of the back wheels to give it steering, and then this front wheel normally is just like a bull race and just runs free. But I'm going to see how this performs. But it was just an experiment really to see if I could get this thing working and steering using the mechanism that I've got there already, and kind of fudging the steering by using this DC motor by sending a signal left and right.